Let us solve this question today. At what temperature is the RMS velocity of hydrogen molecule is equal to the oxygen molecule at 47 degrees centigrade? So this question is from kinetic theory, and here uh, we have to find the temperature, and it is given that at what temperature the RMS velocity of hydrogen molecule will be equal to the oxygen molecule at 47 degree, right? So we know that the formula for the RMS speed is 3 RT by your molecular mass, right? So this is the formula we know. How the formula is derived also, let us briefly discuss. We know that the pressure on the wall of the container, if a container is there, so the pressure on the wall by the molecules, we know that P equal to 1 upon 3 mn Vrms square, and n is the number of molecules per unit volume, m is the mass of each molecule. So P we can write that this is 1 upon m, n we can write number of total number of molecules per unit volume. So small n is n upon v, and v RMS square. If we cross multiply, we will get PV equal to 1 by 3 m n v RMS square. Also we know that this is, let's say, equation 1. Also we know that from ideal gas equation we can represent like this, that PV equal to your nkt. K is the Boltzmann constant, right? And n is the number of atoms. So let's say this is equation number 2. So from 1 and 2 we can write, from 1 and 2 what we can write, at 1 upon 3 mn v RMS square equal to nkt, right? And n gets cancelled, and we required expression for VRMS. So VRMS square equal to, cross multiply is just 3, you multiply here, so it will become 3 kt by small m, that is the mass of each element, each molecule. So this is VRMS, right? So this is the expression for your VRMS, that 3 kt by m. Now we can use this formula. Here, right? That at what temperature is the RMS velocity of hydrogen molecule is equal to that of oxygen molecule at 47 degree. So this is, let's say, VRMS of hydrogen molecule. Let's say this is VRMS of hydrogen molecule, and VRMS of oxygen molecule is also, let's say, 3R, but for oxygen it's given that the VRMS is at 47 degrees. So 47 degree means 47 plus 273 Kelvin, and molecular mass of oxygen is 32 gram, or in kg 10 to the power minus 3 root over. Now as per the question, that the molecular speed, RMS speed of hydrogen is equal to the oxygen, that means VRMS H2 is equal to VRMS O2. So we can write that this is 1 and 2. From 1 and 2 we can write that root 3R temperature of this one is hydrogen, and molecular mass of hydrogen is H2, so it's 2 gram, 2 into 10 to the power minus 3 root, equal to, this one is 3R, 47 273 means 320, 4 7 3 10, 7 4 11 12, so 320 32 into 10 to the power minus 3. Okay, 3 are 320 into, okay, so this is root. Root 3r and 10 to the power minus 3 gets cancelled. So what you will get, root over also both side, if we'll square then root over also will cancelled. So you'll get basically t by 2 equal to 320 by 32. Yeah, this one, this much you will get. So this is 10 and it will cross multiply. So your T will be 20 Kelvin. So this is the answer. So at 20 Kelvin, the RMS velocity of hydrogen is same as uh, that of oxygen molecule, means the RMS velocity of oxygen molecule, which is at 47, that means 320 Kelvin. The RMS speed of oxygen molecule will be same, and the hydrogen molecule. So what we can observe here? We can observe here that hydrogen molecule are generally lighter. So the speed at 20k, whatever the speed it will have, VRMS, right? 20k means smaller temperature, and to have the same speed, to same RMS speed, oxygen molecule require or should be at the temperature 320 Kelvin, 47 degrees. So oxygen molecule is heavier, so at higher temperature it will acquire the same temperature, same speed as the hydrogen molecule, which is at 20 Kelvin. So this is the solution for this question, and we have also discussed here the relationship between the RMS speed and the temperature. Okay, we have established this relationship also. So both these concepts are very important for your exam purpose, both in medical entrance and JE also. The question comes from RMS speed many times. So see you in the next video. Thank you.